All right. Well, gosh, I really did forget how to do this. Yeah. Oh, that's my emails. You don't need to see that. Unless you want to answer some for me. All right. Well, good evening. I'm Christopher Romley. I'm one of the regional directors of NESTA, National Earth Science Teachers Association, and you're a little bit ahead there. I'd like to welcome you to this evening's Earth and Space Education Hour, Real Careers, Real Impact, AGI's Career Explorers. And we hope that and presume that you are NESTA members, but if you're not, there's a lot of great benefits. The education hours, the journal, the Earth Scientists, and e-news, presence on social media, or as I like to call it, anti-social media, but that's another story. And ensuring access to Earth and space science education for all of us. We have, again, from AGI Career Explorer, Real Careers, Real Impact, and we have a number of our presenters here with us tonight, and they are Lindsay Mosa, an education specialist from AGI, Lauren Brazzi, also education specialist from AGI, Garrica Cook, Chief Data Science Branch, Integrated Information Dissemination Division, USGS Water Resources Mission Area, and Candace Hopkins, a physical scientist with USGS Water Resources Mission Area. And so I am going to kind of step out and stop sharing my screen because they have their own information to share with you this evening.
And with that, I will jump in. Thank you for attending. We want to talk about a resource that we at the American Geosciences Institute have created for educators to be able to talk about geoscience careers with their students. And it's not just talking about, but really exploring. We want to have some questions for you to really get you to think like a student and think, what is it that students are looking for in careers? And what is it that what careers are needed now and what skills do they really need in order to fulfill their jobs and their roles. So we at AGI, so myself, Lindsay Mosa, and my colleague Lauren Braze, we have made this in order to, again, bring those career resources to students and really get students to think about how a background in the geosciences can help with various careers. So first, I want to start off by looking at how do you enjoy spending your time? So all of our participants, if you could put this in the chat or turn on your microphone and let us know. But just in general, how do you enjoy spending your time? Or how do you think a student might answer this question? What do you think a student might say about how they like to spend their time?
On TikTok, not me, but I can imagine young students, well, college students too. So
Yeah, definitely on social media. Yeah. Okay, so being outdoors versus scrolling on your phone and playing video games. I'm guessing that's what my kids are doing right now. Spending time outdoors again. Okay, reading books. Love it. Okay, relaxing, hiking, biking, using a telescope. Fantastic. Okay, so like a range of activities. And you can imagine probably even more so with students, they might think of 10 different ways to mention their phone, all the different things that they would do with it. Or, I'm sure some of them like spending time outdoors, but lots of things that can be enjoyed. And then what are main interests or things you care about? So it could be those same things that you enjoy spending your time doing, but some other things that you find interesting or you care about. Collecting minerals, nature, family, faith, dog. Okay, yeah, dogs in general. Perfect. Environmental stewardship, conservation, family, health, Lauren's sick right now. This is very meaningful. Environmental issues. Okay, a number of different concerns. So let's step this up even one more level and talk about issues or problems in the world that you feel strongly about. So this could be issues in your community, education, okay, climate change, pollution, poverty, social justice, clean water, pollution in all forms, inequality, especially socioeconomic inequality. Okay, some really big scale things. And again, those can act on a community level or a global level or a national level, but really things that we're seeing predominantly in the world that, people could be concerned about. And so, oh, yeah, okay, equal access to water, climate change, science funding, absolutely. So definitely things that are all kind of connected. There was a lot of themes throughout your answers, having to do with, things again that can be at different scales. And so when we talk about these things with students, that's very open-ended, and that could seem probably very intimidating or scary in that they don't really know how to solve these problems and really don't know really how to work toward them. But what research is telling us is that students are increasingly concerned with problems like this, and they really want careers that are going to help people and or the environment. And those two categories are really the overarching ideas of what students really want to get at. And so really bringing the geosciences into that is going to help students see that geoscience is all about solving many of these issues. So the first thing you might want to do is formally introducing the term geoscience. And the reason for that is just because so many states and communities use that term earth science, or they even use geology, which are slightly more limiting terms. So if we look at this image here, what you'll notice is what the point we're trying to make about geoscience is that it's really connected to all the spheres of the earth. And so we're not just looking at rocks and minerals, but we're looking at water and ice and the atmosphere and even our interaction with all of these things, the biosphere as well. And so all of those interactions are really going to tell us, the health of our planet and are really going to be able to address a lot of these issues that you all mentioned that you take very personally. And so what we want to help students do is really make connections with what is some geoscience knowledge and then where can we go with this. So I believe Lauren's going to place this link into the chat for people to access, but this will take you to our page on geoscience careers. And hopefully, can everyone see the geoscience careers page?
Yep.
Okay, perfect. And so you'll see the same diagram right there, but what we have here are some resources for individuals and teachers and students to learn about how geoscience careers are generally related to each of the spheres of the Earth. Now, we did lump hydrosphere and cryosphere together, so I apologize if you take offense to that. But we could have endless pages with all of these different types of careers and the connections, and even a little bit of advice about going into careers in each direction. We also have, that was made in collaboration with the American Geophysical Union, our career compasses that look into a little bit more specific careers and how they connect not only to geoscience, but to the different spheres of the Earth. And these are really meant for upper level students. They'll really get into detail about how to take a career path in the direction of, going toward one of these jobs. And so definitely a resource that we highly recommend that you use with students or look through yourself, even just to keep continuously making those connections with students about how these careers relate to all the atmospheres. But not only that, we wanted to be able to connect for the first time how the geosciences help with all of these issues that you mentioned. So revisiting that, what specific issues or problems do you feel strongly about? Well, a lot of them are listed out in the United Nations Sustainable Development Goals. So these, also known as the SDGs, are connected to, or were designed in 2015 in order to connect to all of the different issues that people are seeing across the world and reasonable goals that they set for being able to achieve them. Now, some of the goals are actually due this year, so that's their target date is 2025. Some go to 2030 and beyond, and some are being revisited, saying that, okay, we've made progress toward it, but maybe have not gotten quite as far as we wanted to. But they relate to a lot of the different problems that you all have already mentioned. So climate is right in there. So SDG 13 is all about climate action. And if you go to the UN's page, you'll be able to see that's broken down into what we call targets and indicators. And those are the specific statements for what people want to achieve by a certain point in time. And they're really globally reaching. So they target every nation in the world, and also can get really specific about certain areas that need more help than others. And thank you, Lauren, for putting that into the chat, the link to get to each of the goals, because this is something that we really encourage people to share with students and show them the goals as they relate to not only geosciences, but really a lot of different topics that they're learning in middle and high school. And so you can see poverty's on there. I believe that was mentioned. Clean water was definitely mentioned by a few of you. And so we can find connections between the geosciences and these. So what we want you and students to really think about are, how could a background in geosciences, and we're not necessarily talking about a degree, but we're talking about work, what I call boots on the ground work, or really any connection to the knowledge of the earth and the earth's spheres and systems, and how those relate to achieving these sustainable development goals. And one of the reasons why I bring that up is because the resource that we want to share with you tonight is our Career Explorer. And on this site, it's all about connecting to the Sustainable Development Goals. So there are pages here that are going to allow you to look at the connections that we have helped make between the SDGs and the different things that students learn in their earth science classes. And we also have a list of all of the careers. There are over 160 careers that are on here. And what you'll notice is that some of them don't look like typical standard geoscience careers, but what we call geoscience plus. It's that a background in the geosciences can really help them, with their jobs, and do different types of roles in those jobs. And we really look at the connections on this website. And so another page I just want to make sure that I point out is this For Educators page. So the steps that we're taking during this webinar tonight are part of this Explorer guide, which kind of allows you to introduce student interests, really have them explore all of those, look at the skills that they already have, the things that they want to develop, and then the connections that they make to all of the world issues. And then in the Career Explorer, which we would like you to give a try. So yep, there's a link to that. What students are able to do, or you are able to do as well, is click through the sustainable development goals that you're interested in. So I'm going to use water as our example here, since that is what our focus is for tonight. And when I click on water, what you'll see is there's already 65 occupations that have been selected, and they're in all of these categories here. And so then what I could do is go through and look at the different things that I'm interested in. So if I like analyzing data and I like doing math, you'll see that it starts narrowing down those careers that it's going to recommend to the students that are related to that. And clicking on these occupations, you're able to see all of the different specific careers that are recommended, or do a print summary, which would allow you to be able to keep a record of what careers are recommended. So it's really an interactive tool for students to be able to explore what are all of those different connections there. So you can pick any number of SDGs and any number of things that you like to do, and get those career outputs. And so, because this is meant for educators, we want you to think, what might describe an educator? So if we were looking at this Career Explorer, then what might we click that an educator would like to do, or an educator would be concerned in terms of these sustainable development goals? Okay, so teaching, that is definitely right down here. So you'll see it's probably more than just educators who like teaching, because there's still 63 occupations recommended. Okay, so I'm going to jump in here and say probably concerned with quality education as a sustainable development goal. Okay, possibly leading. So if we just look at these, okay, we can see that there's educational ones. So there's all types of different education careers because we do consider those geoscience or geoscience plus, because again, that's where that background in geoscience could help you achieve these careers, especially if you wanted to teach anything in the earth sciences or even geography, forestry, all different types of education jobs out there that are related to the geosciences. And as I mentioned before, one thing that we are concerned with here is water. So we have some special guests today who are going to share about their careers and how they relate to water, and how we, might look at SDG 6 as a specific example of how to make those connections to, what students find important because everyone needs water and there's water all over the planet. So it should be a big concern that is relatable to all students and populations. And so, yeah, we want to hear from some of our guests today that are going to share what they do with water, and let's hear from them. So let's start with Candace.
I am ready to share, but it says that the host has disabled screen sharing.
Oh. I hope I didn't do that.
Well, okay, got it. Great.
Okay.
Do you see full screen?
Yes.
Lovely. Okay. Well, thanks so much. I'm Candace Hopkins. I am a product owner. My official government title is a physical scientist. And I'm lucky enough to work for the U.S. Geological Survey. We are a bureau within the Department of Interior, so we are federal scientists serving the American public. I just wanted to give you a little bit of background about me. I was very fortunate to have an undergraduate career at Southern Methodist University, including studying abroad and doing lots of fieldwork in Western Australia. By the end of my undergraduate career, I knew that I wanted to focus on water, so I actually did a field camp that was hydrology focused, and that prepared me for my graduate career. And as a note, I just want to say that I've held lots of leadership and volunteer roles outside of work, and I think that that's been a really wonderful thing that's prepared me well for the job market. But two things that were constant throughout my education that's really fun to share with students, and that is that I had wonderful field experiences with really great people, and also having passionate educators like Dr. Jennifer McIntosh, who was my graduate advisor. My graduate research was focused on isotopes and geochemistry, so I was lucky enough to be hired by the Idaho Water Science Center as a hydrologist with a focus on geochemistry. My work included training Iraqi geoscientists in geochemical collection and analysis methods, working on spring tracer studies, doing dye injection experiments in reclaimed mining lands, conducting groundwater quantity studies, using geochemistry to determine flow paths, and of course, lots and lots of field work in support of USGS national and local scale projects and programs. Many of these projects had me in the weeds, gathering, reformatting, and analyzing data from various sources, and of course, meeting great colleagues. One of the fantastic folks that I had the opportunity to work with for years actually needed help on a project and pulled me in to help on a national scale data synthesis project because of my knowledge of groundwater data. So this is where things got a little bit interesting. I was asked to be a product owner for a number of USGS systems that deliver scientific data to the public. In case you haven't heard this term before, it's a term used in software development for the person who represents the users or customers of a software product. It's a bit of project management and a lot of interacting with the people that we are building something for. As a product owner, we spend lots of our time doing user research, so discovering who our users are, or maybe our potential clients, how they behave, and what they want. We do usability testing, so putting real products or mock-ups that we've built in front of people and ensuring that what we have built is going to work for them. This means that we also do a lot of interaction with stakeholders, a lot of setting priorities for projects, helping to shape policy that we have, our actual scientific policy, and just doing a lot of everyday problem solving. And so one of my favorite parts of my job is that every single day is unique. Every single day is different. Typically, days are filled with lots of communication between meetings, software design tickets, and communications with users. And as a product owner, my job is not only to get people the scientific data they need, but also to understand the nuances of some of our data and explain it to users. We're focused on building tools that allow citizens and scientists to easily understand our water resources. And there's lots of planning and project management to make sure that we deliver our software on time, on budget, and with a purpose that serves the American public. I just want to tell you about 3 of the products that I work on that are vital to delivering important water data to the public. These projects that I work on specifically focus on groundwater and surface water availability. So this is looking at both quality and quantity, as much as we can tell from data provided from many agencies. So I'm just going to show you some screenshots of some of the products. I won't talk about them one-on-one, but if you can think back to when COVID was first starting and everybody said, why don't we just look at a dashboard of where all of the cases are? And everybody said, that's not how we collect data. It's actually collected by local hospitals and municipalities, by our different health districts, and by states, but not by one overarching agency. Well, it's a bit like that with water information too, because water is regulated by federal, state, and local governments, and we have a lot of other interested groups such as citizen scientists who are collecting the data. So my team and I work to build a lot of tools to help deliver data from these many different layers of government to scientists, citizens, and policymakers so that we can make better decisions about our water resources. If you have any questions about being a product owner, I would love to touch base with you later. Thank you so much, and I hope that your students might be interested in this type of career track.
Great, thank you so much. All right, let's hear from Garrica next.
All right, I'll make an attempt here to share my screen appropriately. Okay, everybody seeing the full screen?
Yes.
Not the presenter view?
Yes.
Okay, great. All right, well, good evening, everyone. My name is Garrica Cook, and I am the branch chief for data science in USGS Water. The U.S. Geological Survey is a federal scientific bureau within the Department of Interior, as Candace has already mentioned. We have 5 different mission areas, and water is the largest within the bureau. The USGS tagline is Science for a Changing World. We conduct basic scientific research and data collection on natural resources, natural hazards, ecosystem health, and how humans alter and interact within those systems. As data scientists within USGS Water, we ensure that our scientific methods are efficient, reproducible, and follows open data science principles. So the primary mission of USGS Water is to provide reliable and timely scientific information about water resources within the United States. Water is a very important and limited resource that has multiple applications, some of which I've listed here on screen. And to support the nation's needs for water use, USGS collects high fidelity, real-time data on water quantity and quality necessary to support modern water prediction, national level or regional level assessments of water availability, and to then deliver that information back to the public to support various levels of decision making, management decisions, or in some cases, just recreation. I wasn't always in the water sciences. My career path was not a straight shot from education to the career or the job that I hold now. Like is depicted on the left side of the screen, my path was much more like the right. I held many different jobs. I worked in various different ecological domains, but I always had an emphasis on public service and stewardship of natural resources. And so I'm going to talk a little bit about what my career path kind of looked like and why that might be of interest to some of your potential students. So this graph, not the greatest graph in the world, but it depicts 30 years of education and work experience. So I did start as a starry-eyed undergraduate at Western Kentucky University with a double major in math and biology. And when I graduated, I was offered a graduate research position at Colorado State University to study the dynamics of East African ecosystems. And yes, I got to travel to East Africa. I lived in Serengeti National Park for 7 months. I was following around elephant herds and doing vegetation measurements to look at how savanna ecosystems can move between a closed woodland state to an open grassland state and every stage in between. However, my dissertation was very dependent on a very complex and ultimately faulty ecosystem model. Had over 300 parameters. It was a lot. I couldn't get trees to grow in the model, and I needed that to test some of the hypotheses in my dissertation. So cutting the story short, I ended up making the very difficult decision to start over. And that involved picking on one of the skill sets that I had developed during my PhD tenure as a graduate student. And that was some of the GIS skills that I had picked up because I was generating data that would feed into my model. So I started over as a student intern, first with the Park Service and then with the state at Colorado Parks and Wildlife, where I was mapping critical animal habitat. And then those internships got me into the door in a permanent federal service with USDA APHIS. APHIS is the Animal and Plant Health Inspection Service. That's an agency within the Department of Agriculture. Their mission is to prevent the entry, establishment, and spread of invasive species that can impact agricultural and natural resources. I spent about 10 years with APHIS, kind of leveling up in my GIS skills, supporting field operations, before being offered the opportunity to do a lateral, which is a move from one job to another within the agency to the science and technology arm. And then I started developing machine learning models to predict the likelihood of invasive pest species that would be introduced, and doing that on a national level so that field inspectors could use that information to target early detection of these plant pests, and then be able to implement eradication regimes before those pests or diseases would establish and cause severe economic harm. After doing that for a while, I job hopped over to the animal health side and basically did a very similar job as a risk assessor. But the job was essentially the same, where I was predicting the likelihood of foreign animal disease introduction into the US through foreign trade, importing live animals or animal products. And again, helping agricultural inspectors target inspections at ports of entry. And I was thinking, this is great. You know, I'm building new products and new methodologies that help field managers protect our natural resources. Maybe I'll take another crack at this PhD. So I went back to CSU with a new thesis, a new committee, taking classes because enough time had passed. I had to retake some of my classes. This time, what I had trouble with was balancing a full-time job, going back to school, and starting a new family. I was pregnant while taking some of these classes and holding down a full-time job. It was a lot. And I ended up having some health issues. So, life intervenes, things happen. And I realized that I needed to better manage my health and perhaps do a career switch. So again, a little bit of a backtrack. I applied to a job with the U.S. Geological Survey to supervise a data science team. I was so excited when I got in with USGS because that's always been my dream agency. And then was promoted to branch chief for data science. So when talking to your students about, navigating their careers and kind of prepping them for what lies ahead, you never know what you're going to encounter, what challenges are going to happen to you, how life can intervene and derail your plans. So it's important to be flexible and to be opportunistic. It is a journey. If you encounter the moment where perhaps you need to do a career shift, like I did, I moved through different fields from East African ecosystems to plant health and then animal health and then water resources. It's helpful to map your strengths in terms of what leadership roles did you have in your work? What level of autonomy did you have? What creativity or innovations did you bring to your job? How did you impact decision making? So on and so forth. So those are important details to really kind of bring to your resume when you're trying to do a career shift, because those are transferable skills. And lastly, I would just recommend to not fear change. Sometimes change or career shifts, in my case, can lead to great opportunities. So with that, say thank you. And if anyone has any interest in being a data scientist in whatever field of natural resources or ecological research that you're interested in, I'm always interested in talking about that and answering any questions that you may have.
Amazing. Thank you. I love that career path, by the way. So I know you said that wasn't the best graph ever, but I think it's pretty close. I like it.
Right. I'm going to, did I stop sharing, or I still sharing?
Still sharing, yeah.
All right. I got to figure out how to undo the share now. There we go. Nope, that's still sharing.
I think I got you. You guys can see my screen now, correct?
Is it rocks?
It says connecting science education. No?
Oh no. We see a pretty shoreline.
That is not me.
That would be mine. And okay. So is it gone now? All right. Yeah. Sorry.
Did it change over?
So I see a notice that you started to share your screen, but I'm still, oh, I have to go to view options up at the top.
It's sharing, Lauren.
It looks like it's still sharing my screen, and I'm not seeing the option to unshare it.
Okay. I believe I stopped it. There we go.
Take 3.
Start over.
There we go.
Good. Awesome. Well, thanks, Jerica, because the end of your talk is a perfect segue into my talk, which is all about how I've connected science, education, and water in my pathway into the geosciences. Once again, I'm Lauren Brozzi with American Geosciences. I have recently been sick, so I apologize for my raspy voice and if I have to mute myself for a cough, so just bear with me a little bit. And then we'll see. Great. So I'm going to give you kind of a background of how I became an education specialist with AGI, but especially some of the roles that I had related to water. And so background, I went to Vanderbilt University. I got my BS in secondary education and in chemistry. I knew from a young age when I was in high school that my chemistry teacher was who I wanted to be. He was exciting. He blew things up. He made messes in school. It was very interactive. It was the kind of career I always wanted. And when I went to college, it was kind of, I knew this going in and I became what I wanted to, which is kind of a unique experience in college. I know there's at least with my colleagues, my friends, there were a lot of change in careers. it was always really engaging. I went to study abroad in Florence, Italy. And when I was there, I taught English and actually worked with a nature center in Italian. And so I kind of learned Italian while I was out in nature. It's a common language. You can look at soil, you can look at leaves, you can hike. Everyone's able to work together, even if there is kind of a language barrier. And so that maybe was the first hint that I wanted a career in the geosciences. But again, I went back to the United States and graduated. And then I did end up teaching science at a school in Franklin, Tennessee. I taught chemistry, physical science, astronomy, kind of jumped around the board, but always was really interested in the sciences, obviously. While I was teaching astronomy, I believe I read a news article about water on Mars and saw the movie Interstellar and got really interested in just space and what's out there. And my students were probing me with questions about, you've convinced a lot of us to go get your master's and to pursue astronomy. Why aren't you doing that? So I decided, okay, good idea. So I went to Case Western Reserve University in Cleveland, and I studied the Earth, Environmental, and Planetary Sciences. And I'd say this was my biggest career switch because it went from being in a chemistry lab, doing controlled reactions, into realizing all of the craziness that comes with studying geosciences. And I studied cosmic dust, and you can see in the picture in the bottom right, I essentially scooped up some sand samples that we had in the lab, collected from all over the world, looked at sand underneath a microscope for years, sorted out particles with a paintbrush, and then analyzed them in the lab. And so I was able to determine the different types of cosmic spherules. Some are, these all are actually from space, but I more so was interested in a type of particle called a microtectite, which is actually Earth impact traveling out into space and then coming back down to Earth. Very unique. But one of my favorite parts of studying these little tiny spherules was I got to go to Antarctica to collect them at the end of my degree. So another impactful opportunity I had was through the ANSMET program, or the Antarctic Search for Meteorites. And this was my first real research interaction with water, or, ice. And so if you can see in the top picture, I traveled there. We were there for 3 months out in the field with 6 people. We lived in a tent. You can see in the bottom right, that's actually a picture of my 30th birthday. If you look really small in the middle of the table between us, there's a little cake with a 30 on it. And that's the size of a tent we lived in. And that was what we called our science tent. And we each had a roommate in our own tents and lived out there for months and collected meteorites in the ice. And so what I was there for collecting meteorites, but also to help monitor the blue ice, which is where a lot of meteorites are deposited in Antarctica. You can see in the top right image an terminal moraine of one of the glaciers, and you can see that all of that blue ice is kind of depositing all of these rocks from underneath. They kind of get pushed up in a conveyor belt fashion. And that's a great place to look for meteorites. And so in the top left image, you'll see all those little red flags. The process is you're doing transverses across the ice and across different moraine piles and flagging every location where you think there's a meteorite. And then we go back as a team and we document it. We take pictures. Everything's really sterile. So you're in gloves. There's tweezers and tongs to help you pick it up. You have to somehow open up this little plastic bag with these massive mittens on, which is always a fun task. After documenting the meteorite, then you bag the sample, and then we sent them back to NASA and the Smithsonian to analyze. And so that was a great experience. And my first field experience with research, since my master's was primarily in the lab. And so once again, going from a chemistry lab to a geology lab or a planetary sciences lab. And now I've gotten some field experience. And throughout all of those different careers and different projects, I liked the science. I really liked what I was doing, but it fell, obviously Antarctica was amazing, but it fell short in terms of kind of how the work was impacting other people. And so when I got back from Antarctica, I actually got a position with ORISE, which is the Oak Ridge Institute for Science and Education. And I was a postmaster's fellow at the US EPA Office of Research and Development. I was not even aware that there was an Office of Research and Development until finding the job posting. And I was lucky to have fallen into this career. And I'll talk more about ORISE or EPA in a second. First, I wanted to do a side note about Oak Ridge. I'm not sure if the educators on this call are aware of it, but it's a great resource, especially for upper level high school students, to be aware of that once they finish their degree, there are internships, there are science research positions that they can have before going into a master's or after a master's. It's kind of a break between getting a master's and a PhD. There's a lot in internships over the summer. There's a lot of opportunity. And so I'd highly recommend you to look into it. And in addition, for educators, there's PD opportunities through Oak Ridge. And also they have some materials on their website also for students and for lesson plans. So it's just a really good resource to use. And it utilizes a lot of the research that students and master students, PhD students are doing while they're in their Oak Ridge ORISE fellowships. So I highly recommend checking that out and recommending that to students. So when I was with the EPA ORD, I was in Cincinnati, Ohio, and I actually took my job interview while I was in Antarctica, and there was a 16-hour time difference. It was over a satellite phone. It was quite interesting. But when I got back, I was excited for my first day of work to be on COVID day, first day of shutdown in Cincinnati. So I went in there with this whole project that I was supposed to be in charge of with field work. I was going to be training employees, looking at low-cost field work methods so that people that are traveling to mining sites, which is the initial project I was hired for, could bring as little equipment as possible for as low as cost as possible, but still make an impact. Fun times with COVID, my job completely switched and I became in charge of a project with groundwater and surface water interactions with my EPA advisor, Robert Ford. And so instead of traveling to different sites and looking at research, we actually looked at how pollutants travel and how groundwater and surface water interact. And so this is one of our study sites. It was a great learning experience because we got to get out to a local location. This is a river in Cincinnati, and we had the 4 upper field sites on the right, the 5 lower ones near the mouth of the river that enters just a larger stream, a larger river. And I got to learn techniques that I never would have experienced, such as installing piezometers, or they're kind of like groundwater wells where you're taking a fence post and there's just the 2 of us out there installing these this technology and this equipment all day, which was really entertaining because I had never done a manual job before. I was just in teaching, and then I was in the laboratory. So this was a great experience. I learned a lot about equipment. I learned about why it's important to know about surface water and groundwater interactions. And there are a lot of different connections that we were able to do in the next part of my job, which again became out because of COVID. And so the next part was looking at our next sites, Cooper Creek. This is a drone overview, which I might skip for time. I know I'm running a little bit long. But one of our other field sites was looking at this location, which had an outlet right here from a city above, or city stormwater above. And as you can see, it's kind of a little grainy, but it has different impacts that you can see of erosion on the sides. And so this is a very flashy stream, and it really impacts the animals living here and along with the infrastructure, because there's parks right up on the top of these ledges. And so I'm just going to skip forward a little bit, but that's online if you're interested in looking at it. Let's see if I can. This is an image of part of the stream during low flow. And then, like I mentioned, it's a very flashy stream. That's during high flow, and it happens within minutes. So it's very quick. And part of the project with the EPA ORD was to figure out the impacts and how fast that transition would occur, to figure out also the interaction between the groundwater surface water, how long would it take for that the high water to drop back down to the low water, but then also how to fix it. And one of the partnerships that we worked with was the Cincinnati Office of Soil and Water Conservation, and we decided to install rain gardens up above in upstream locations where it would kind of help dampen the effects of all of the high water. This is actually, it's a video, but I don't think it's going to play. One of the manholes that was overflowing, the sewer overflows. Another reason why it's important to think about how much water is leaving the infrastructure at the top and entering nature down below is that you assume it kind of goes into a river and all is well, but really it overflowed the manhole and that's sewage water going everywhere. So something that kids really don't think about as water goes into storm drains off the road near their school or their house is, okay, it's gone, all is well. Well, there are really huge impacts down the way that not only affect the animals, but think about the pollution also that could be impacted. And so we installed rain gardens. Let's see if I can skip this. Upstream at one of our high schools. And this was kind of the third part of my time with the EPA Office of Research and Development, was because I had a background in education, this project kind of came about with my experience. And so we installed a rain garden with the Hamilton County's Soil and Water Conservation District. And then we developed learning modules where students could then utilize the rain garden to learn geoscience techniques such as surveying. We installed a piezometer to look at groundwater surface water interactions. We used temperature probes to look at how temperature varies in the soil when it's dry versus when it's wet. There's a lot of opportunities you can do with a rain garden, in addition to just helping manage and mitigate the problem of all of the stormwater overflow. So that was kind of my first real experience, taking the experiences I had in the field and applying them to education, which I loved. And then that led me to my career with American Geosciences Institute, where I get to take all of the experiences I've had in research and also my passion for learning about research, whether it's about water, clean water, or other topics, and apply them to the education sector, whether that's with teachers or outreach specialists. It's been really rewarding, and it's definitely the best mix for me in a career path of, I tried out a bunch of different ideas and a different hands-on in the lab, interacting with people, individual research. Again, I just echo Jerica's statement of be flexible, forgive yourself if you kind of go down a path you don't want to go down, but knowing that it's always time to pivot if you want to pivot, and there's lots of opportunities to go to after. Thank you.
All right, and with that, we are going to hear from our last speaker, who was not able to be here with us tonight, but was able to record her presentation for us in preparation for that. But it really builds off of what Lauren was sharing, as this is someone who works on a local level, not just with water, but with rain gardens, as Lauren mentioned. Let me see if the sound is going to work here.
Hi, everyone. I'm Beth Luce with the Conservation Foundation.
Did that come through? Yes. Okay. Beautiful.
Hi, everyone. I'm Beth Luce with the Conservation Foundation, and I'll be covering some ideas on careers on a more local level concerning water, and specifically in conservation. So the Conservation Foundation is located just outside of Chicago. We serve DuPage, Kane, Kendall, and Will counties. And we are a land trust. So we save land and we save rivers. We help to preserve land that may be developed to keep it a green space or keeping our waterways clean, and as well as promoting environmental stewardship. So we've been able to save over 36,000 acres at this point. That's what this map is over here. All these little dots equal something that we've been able to preserve. And so we don't just think about waterways or just land. There's a lot of other things that the organization does, especially around environmental education and outreach and advocacy. A little bit about me. So I'm the Conservation at Home Program Manager, and that is our program that focuses on how individuals can take steps in their own yards and green spaces to be a little bit more sustainable. I came to this actually through adventure travel and marketing prior to this career, where I was able to see some really beautiful places around the world, but that really drove me to want to conserve those places and help save those areas. So I went back for my master's in environmental science and sustainability. I would say that a lot of roles in conservation and especially in water conservation don't necessarily need master's degrees. Bachelor degrees are usually are good, but depending on what area specifically you're looking to do, sometimes the more kind of deep science areas may need some master's degrees too. I did get my start though through the Master Naturalist program through our University of Illinois Extension. So I would recommend that actually as a really great way to get a taste of what this field will be before maybe launching fully into a college degree. So in my role specifically, I help people deal with rainwater issues in collecting in their own yard, which then also can impact community flooding. So, flooding so bad that it shuts down roadways or is standing water for a long time that really promotes mosquito breeding, that sort of thing. We talk about water pollution from the runoff of what's in your yard and how that actually impacts our stormwater systems, which then go directly into our rivers and streams. And then also just water conservation, not wasting water when you don't need to. Just a quick visual of what that type of thing looks like and what kind of things do impact our water systems that you may not be thinking about in your own home. I focus a lot on native plants and what you can actually do specifically to plant to help not only the water issues in your own yard, but again, helping the greater community with some other things, as well as supporting pollinators and other wildlife and providing some habitat there. We talk about rain gardens, and this specifically would be an idea of building a rain garden and the structure of it specifically to collect the water in a spot where it is away from the house and not somewhere that you will be necessarily walking or using, but then planting these plants that can bring those the rainwater all the way down kind of a couple feet into the ground versus with turf grass where it's just sitting on top because it only has a couple inches of those roots. We also talk about water conservation and using rain barrels. So not only is it free water to be watering your gardens, but even just by collecting, so this rain barrel in the picture here is 55 gallons. Collecting that water in a rain barrel is another 55 gallons that isn't inundating our stormwater systems all at the same time because, with climate change, we have these bigger, more intense rain systems that are moving through. So it's dumping a lot more water in a shorter amount of time. So even doing something like collecting the water and then releasing it, on a sunny day when there isn't a lot of saturation in the area, it can even be helpful for water conservation. Conservation Foundation also does other water focused work. We host river and stream cleanups. We coordinate citizen science projects like our winter fluoride watchers, where people are testing the water for chloride levels. Throughout the winter, we do live in Chicago, so we have some pretty intense winters where we need to make sure that the ice isn't forming too bad on the roadways. But unfortunately, a lot of municipalities and organizations put way too much salt on the roadways, which then again end up in our rivers and streams, unfortunately. So that's a way to monitor it. And then our Salt Smart program is a way to help teach these municipalities more sustainable ways of managing that for the public. And then we provide a lot of education and outreach programs for the greater community about water conservation. And finally, something kind of on a more regional level for us, we staff watershed work groups so that we basically coordinate and collaborate with a lot of different municipal agencies and pool our resources and expertise to help the health of our watersheds and our waterways in our area. And I do want to mention that, you don't necessarily have to be someone that loves being outside all the time and get your hands dirty like I do in order to have a role in conservation and water health. But because on these teams, we have people that do statistical analysis, project management, accounting, and graphic design. So if that's kind of a skill set that a student has, but they don't necessarily want to get dirty, they can choose one of these pathways as well. And I did want to quickly mention our Conservation at School program. So that is something that I actually is why I have to record this video ahead of time. I wasn't sure if I would be back in time for one of our pollinator garden installs at one of our local schools. We work with teachers to provide curriculum and lesson plans, just some ideas of being able to utilize a pollinator garden on their schoolyard. There is research that does show that it helps improve focus, lessen anxiety, and boost memory for students as well as, again, providing back to the local wildlife and pollinators and that sort of thing. So even if you, start planting a few things around your own schoolyard, it does benefit the ecosystem quite a bit and your students. So thank you very much. I apologize again for not being there. But if you have any questions, I'm happy to answer them. And here's my information as well as the link to our website if you have any more questions in general about our organization. Thank you.
All right, so hopefully you see the range of careers that are out there that can connect to one topic and all the different ways to get the pathways to get to those careers, and really make those connections and just affecting the world in so different ways. And also just having that conversation with students about that not every career path is linear and that, you can always they call them step back. So both Garrica and Lauren both kind of said, yeah, I'm going to take a step back. And like, I don't really see it that way at all. Just, going in a different direction and being open to those opportunities and seeing kind of like what it's going to bring to you and what connections you can make between those different pathways. So you'll see a few of the speakers shared their information to be able to contact them. But we're going to drop our email in the chat as well, because then we can forward any questions that people might have for any of the speakers or for us at AGI. So we have a lot of resources on our website that connect to these topics, and then the Career Explorer that we shared with you. Hope that you'll be able to use that with your students, and especially that For Educators page. So it really helps make those connections to standards and other resources that our partners have on all the different career opportunities that are out there. So with that, I will hand it over, I believe, to Chris or Artis to do the closing.
Yeah, that was great. Awesome. I could not just K-12 students, but college students who are still kind of wondering what they're doing, or to kind of gracefully recruit them into the geoscience.
Yeah, absolutely.
Especially in an intro geology course that kids need to take for Gen Ed or select for a Gen Ed science class. So with that, we'll hope you'll join us in about a month from now on June 17th, same time, for the next education hour. A little bit different, using NASA Earth data there. And then we have a July off, and then we resume in August with AMS courses, which I have taken back when I was a K-12 teacher. That was one career ago. So I too have had a varied pathway. That's what keeps life interesting, I think. So there's that. And then please join NESTA if you're not a member already, and unlock a whole bunch of other opportunities and professional development and just lifelong learning experiences all the way through. So thank you very much. If there's any questions, concerns, we don't serve dessert here, so you'll have to do that on your own since we're not in person. Hi, Artis.
Oh, I first of all just want to thank everyone. This was fascinating to listen to it. I was particularly impressed that it was an all-women panel. And I really liked the beginning of your approach where you said, what do you like to do and what are you interested in? And, I was listening to the first presentation about I became a product owner. Is that what it's called? Yeah. And I was like, how many kids grow up to want to be a product owner? It's like, how do you get from point A to point B? So it was just really kind of interesting to listen to all of your stories. And I appreciate the time you took to do this and to put this presentation together. Certainly, we've got to find a way to get more of our young people involved in the geosciences and in environmental concerns and taking care of our planet. So I appreciate everything you're doing. I think this is a great tool. And although we didn't have a lot of people here tonight, this recording will be shared with our membership. So I'm hoping that quite a few people will take advantage of watching this recording. So thank you.
Yeah, we definitely appreciate you having us, and then the opportunity to share not only the resources that we have, but getting the word out about talking about these careers. If you don't expose students to them, they're not just going to find them on their own necessarily. So just encouraging them to go in the direction of the sciences and all the places it can connect. So thank you.
I also appreciated, just as an addendum, I know a lot of students think you have to get a PhD to be a scientist, and there are just so many careers out there
Right.
that, as you mentioned, some of them just bachelor degrees, some of them masters. But I think that's a point of awareness we as educators really need to impress with our students as well.
That was one of our awesome, the key thing to the Career Explorer versus those career compass pages Lindsay shared earlier, where they kind of give a traditional path of undergraduate. If you're going to be professional, you have to get your doctorate, versus the Career Explorer is really that geoscience plus aspect of it's geoscience is everywhere, and it's just how you can kind of connect to it. And there's many pathways into the subject.
All right. And on that note, I think that's a good note to end. So I'm going to stop recording.